Hi students, in our previous video we have discussed about the concentration of the ore, and in this video we are going to discuss how to extract the crude metal from the concentrated ore. We have discussed many concentration terms of the ore. And now what is meant by the word crude metal? Means we have removed the gonze particles, that is done through the concentration process, and there we got some ore. Most of the ores of the metals, they does not occur in their native state. They will be occur in a combined form. These ores of the metals can be extracted into the metal easily from the metal oxide. How are the metals can be extracted? The metals can be extracted from the ore of the metal oxide. By the easiest method. But there are only few of such ores which occurs in their oxide state. Most of the ores will be occurring in the sulfide ores. Most of the ores will be occurring in the sulfide ores. Only few ores will occur in the oxide form. They too does not occur in the pure oxide form. They will be combined with some so-called vapor, or they will be combined with some carbon dioxide. So we need to remove these volatile components from the oxide ore. So the process now we are learning as to extract a metal from its oxide ore is done by a process called calcination. What is the process it is called? Calcination. We are going to learn three main processes in this session. That is, one of the point is called calcination. What is calcination? Heating an ore below its melting point to remove the volatile components present in the ore. What are we doing? We are going to heat the ore below its melting point to remove the volatile components present in it. Usually this heating is done in the absence of air. That is, in the absence of oxygen. We do the heating. What do this process of heating an ore below its melting point to remove the volatile components in the absence of air is called as, the calcination. Generally, the ores that are present in the form of the carbonates were heated in this method. Ores of carbonates carbonate, the limestone, we know. When this limestone is heated, when the limestone is heated, the ore of calcium carbonate, when it is heated, it will be forming calcium oxide plus carbon dioxide gas. Whatever is occurring in the form of gaseous state, that will be escaped easily to the environment. This is what we call as the volatile component present in the ore. Where is the volatile component present? It is present directly in the ore. So heating an ore below its melting point to remove the volatile components present in the ore, it is so called, we call as the calcination. We are taking one more example. In this case, we have heated an ore of calcium. We have heated an ore of calcium. And at times, this calcium ore may be formed in a combined state. It may not be present in a direct state. It is in a combined state with magnesium carbonate. It is called as dolomite. What is this one called as the dolomite? The calcium carbonate and magnesium carbonate together, they were present in the ore. So when you heat such kind of ore, they will also decompose to give the calcium oxide. Here you can see calcium oxide, and also the magnesium will form its magnesium oxide, and from here one carbon dioxide, from here one carbon dioxide, they will be escaped in the form of carbon dioxide gas. We have discussed up to now about the carbonates. At times, in the ore of iron, Fe2O3, there will be some water particles present in the ore. We can say it as the hydrated ore. What is that one called as the hydrated ore? Hydrated ore means it is combined with some water molecules. When you heat this ore, the water molecules will be evaporated in the form of the gas, leaving behind the iron oxide. These are some of the examples to study how the ore is heated in the absence of air to form its oxide from its combined form. That is to remove the volatile matter present in the ore. Why to convert the ore into the oxide form? Most of us will have a doubt, because any of the metal can be extracted directly. Any of the metal can be extracted directly from its oxide ore. Means it is easy to extract a metal from its metal oxide. So any of the ore, first we try to convert into the oxide form. But the problem is only few ores occurs in their form of carbonates, which can be directly converted into oxides. But most of the ores occurs in the form of the sulfide. Such kind of sulfide ores cannot be converted directly into a metal. Then we need to convert that sulfide ore into an oxide form, into its oxide form. Now we are going to see what is the process called. So we had got explanation, that is, when the ore is present in its sulfide form, it needs to be converted into its oxide form. That process we are going to call as the roasting. For that we got one definition. Heating a sulfide ore below its melting point example. Zinc sulfide. My example is zinc sulfide. Zinc occurs in its sulfide ore, that is called ZnS. It is converted into its oxide by heating in the presence of oxygen. In the presence of oxygen. Which is heated in the presence of oxygen? Zinc sulfide is heated in the presence of oxygen to convert into its oxide form. In order to balance, we are using 2 moles of zinc sulfide and 3 moles of oxygen. How many zinc you find here? 2 zincs you find. Each zinc will combine with 1 oxygen. So 2 moles of zinc oxide are formed as one of the product. And the remaining atoms in the reactant, sulfur, will react with oxygen to be converted into its oxide. How many sulfurs are there? 2 sulfurs are there. So it is going to form sulfur dioxide gas. It will be escaped. So in this roasting, what are we doing? We are heating the sulfide ore below its melting point in order to convert into its oxide in the presence of oxygen. There are many examples here. We can use PBS, galena or lead sulfide, it is called lead sulfide. It is also heated in the presence of oxygen to give the lead oxide and also the sulfur dioxide gas and also the sulfur dioxide gas. But here there is a main point to be observed. These oxides, in which cases we have studied? In the case of calcination or in the case of roasting. The common product what is the oxide. From them we need to get our metal. We will discuss now how to get the metal from the metal oxide. And prior to that, we got one byproduct here. What is the byproduct here? Sulfur dioxide. These gases of sulfur dioxide are further used in the manufacturing of sulfuric acid. In the manufacturing of sulfuric acid. If we take one more example of an ore of the copper. Now we are choosing one more example of the ore of the copper. That is called as copper pyrite. What is it called as the copper pyrite? If you study it, the copper pyrite CuFeS2, it is called as the copper pyrite. Now you can observe the ore of copper. It is the chief ore of copper. In this chief ore of copper, what is the chief ore of copper? Copper pyrite. What are the group of atoms you can find? There is a sulfide and also there is the iron present here. Then how to get only the copper from this copper pyrite? This is a mixed ore that is present along with iron. We are not having only copper sulfide, we have iron also. Now we need to heat this kind of ore at a very high temperature. At a very high temperature to get them in a molten state. To get them in a molten state. This process to convert an ore into its molten state. We are giving presence to be heat here, wants to be checked here. Please observe, here we are going to heat the copper pyrite in the presence of oxygen. If we go on heating, the copper will be separated along with sulfur to form copper sulfide. To form copper sulfide. Copper sulfide. And iron also will be converted into its iron sulfide form. Into the iron sulfide form. For the balancing, I am using 2 moles of copper pyrite. 2 moles of copper pyrite when heated in the presence of air. Heated in the presence of air. What are we getting? We can find there are 4 sulfurs here. 2 2s are 4. 2 coppers are there. We mentioned 2 coppers can combine with 1 sulfur. That's all. So the coppers are completely used up. And there is only 1 sulfur. How many irons are there? 2 irons are there. Each iron will combine with 1 copper sulfur part with 1 sulfur. But there are 2 irons here. So I had used up 2 moles of FeS. 2 moles of FeS. Now out of 4 sulfurs, we used 1 sulfur here, remaining 2 sulfurs here. Totally up to now 3 sulfurs are used up. Remaining sulfur with the oxygen, it will be converted into sulfur dioxide. It will be converted into sulfur dioxide. So please observe the point very clearly. The chief ore of copper occurs in the form of copper pyrite, that is mixed along with iron also. In this case, we need to heat this ore at a very high temperature below its melting point to convert them into the molten form. To convert them into the molten form. What are we calling this one as? We are calling this one as the smelting. Yes. Now, once we get the copper sulfide and iron sulfide, we will still continue this process. Which process? We got the metal sulfide ore. What is this one? Metal sulfide ore. Metal sulfide ore. There is one problem also to observe. In this ore of the copper pyrite, there is an impurity. What is there in the copper pyrite? In the copper pyrite, the impurity that is present is FeO, iron oxide. Impurity present in the copper pyrite is the iron oxide. 2 things we need to do now. We need to remove this iron oxide and also we need to convert our copper sulfide into copper oxide. Please observe, in order to remove this iron oxide from the copper pyrite, that is from the copper ore, we will add silica. What do we add? Silica. So that this silica will be combined with the impurity that is present in the ore, that is FeO, iron oxide, and this will be separated in the form, that is what we call iron slag. What is this one called as the iron slag? FeSiO3. The impurity that is present in the copper ore, FeO, is removed with the silica in the form of iron slag. Slag is the molten substance that is collected above the ore. It is the waste material, unwanted material Now we need to go back to our concept. What is the concept we left behind? We obtain our copper sulfide. We obtain our copper sulfide. This copper sulfide need to be converted into the copper oxide. Let us see here how to do. So we got the definition of smelting now on the board. You can write it also. The roasted ore. We got the copper pyrite as the chief ore of the copper. The roasted ore is mixed with coke and sand. Two main points they are using. Coke and sand. The formula of sand is nothing but silica. SiO2. What is the purpose of silica? The purpose of silica is to remove the impurity FeO, iron oxide, from the copper ore. And what is the purpose of coke? We'll come across in the next explanation. And smelting. Smelting means the process of which to get the metal oxide from the ore of the copper by the process of heating. We call also as the smelting. Here we are completely oxidizing this so-called copper ore. We had already balanced two equations. How to convert a sulfide ore into oxide ore. Here we got the copper sulfide ore. This copper sulfide ore on oxidation, that is heating in the presence of oxygen, that is called for the roasting, it had given copper oxide. So from this copper oxide we can get our copper metal. We can get our copper metal. In this so-called extraction of crude metal from the concentrated ore, especially when we are dealing with the copper ore, there will be some unreacted Fes present in the reaction. Some of us will have a doubt. The copper pyrite is there, that is CuFeS2. In the we call Fes. What will happen for the Fes? The Fes also will undergo oxidation. It will also form FeO and also SO2, iron oxide. For the Fes, it will also further undergo oxidation to form FeO. But some unreacted Fes will be left behind. That Fes will be reacted with Cu2S, that is left behind, unreacted, little amount. These two combinations, Cu2S plus Fes, together we call it as the copper main. What do we call it as the copper main? Objective question. What is copper main? In the copper ore, the Cu2S plus Fes, it is called as the copper main. So up to now we have discussed what is calcination and roasting. In both the cases, we studied the formation of a metal oxide, but we didn't get our metal from the metal oxide. Now we are continuing how to get the metal from the metal oxide. So whatever it may be, in the roasting or calcination, the common product is a metal oxide. Such kind of metal oxide need to be converted into the metal. See, we got a general equation here. MXOY. The suffix indicates their coefficient. When they are reacted with, means the metal oxide, we can also write as MO. Metal oxide is reacted with coke. During smelting, we said we had added carbon. That is a coke. The oxygen, free from the oxygen. So can we could say in the reactant metal oxide is present, but in the product we have only metal. Do you remember the reactions in which a substance loses oxygen? What do we call? We call them as the reduction reactions. What do we call them as the reduction reactions? How does this reduction take place? The reduction reaction takes place in the presence of an reducing agent. Yes, here coke is making the metal oxide to lose the oxygen. So the purpose of this coke, it is acting as reducing agent. It is acting as reducing agent. What is the purpose of reducing agent? It makes the metal oxide to undergo reduction. That is the reason we say XOY is the compound. Why moles of coke are given? Here there is one oxygen and there is one carbon. What are they forming? Carbon monoxide. They are leaving behind our metal. Now, in our so-called chapter metallurgy, in every case we cannot use carbon as the reducing agent. In that place, we may use another metal to reduce the metal oxide. These concepts that to use a particular reducing reagent will be discussed in the next video under the heading Ellingham diagram. So up to here we are going to conclude the topic how to convert a metal ore into the metal. What are the steps that are involved in converting a metal ore into the metal? The metal ore is first converted into metal sulfide. Then the metal sulfide is converted into metal oxide. Again, the metal oxide is reduced to metal. These are the steps that are involved in converting a metallic ore into the metal after the concentration of the ore. It's not that we are getting a pure metal ore. Again, this metal needs to undergo refining. Those topics will be discussed later. But our upcoming topic is very important topic, children, that which will act as a reducing agent. And why do that will act as a